Hi, I'm going to show you a little bit about running the the catmain.c program we created in the previous video. So if you recall there, we hash included the cats.dat structure. We created two cats. I actually populated one of them with some data that was fluffy, and I wrote that struct out to a file called cats.dat. In fact, I'm going to use the terminal for this, which I understand is very old school, but that's how I roll. So here you go. At the very bottom of this listing, right here, you'll see the cats.dat file, and it's 80 bytes long. So presumably, if you printed out the size of the cat struct, you'd get 80. So it's 80 bytes. We didn't have to know that because we use size of. So we're going to look at the, first I'm going to compile the program to show you how that works. And I'm going to compile it using the command line, probably not the way you compile things, but this is what Visual Studio Code does. If you watch carefully in the terminal window when you compile a program, you'll probably see GCC fly past like this. So here's compiling it. Now, it took me 3 times, and I got rid of a bunch of errors and warnings I had the first few times, so I'm not perfect, but I did get it to work. And under Linux, which is what we're looking at here, that produces a file called a.out. Yeah, it's a stupid name. It's some ancient convention that Unix had. But you can see it's really fresh. It's just a little bit later than the previous cats.dat. So if I run the a.out file, it's going to create, in fact, let me get rid of the cats.dat so you can see this. Okay, cats.dat. I didn't get rid of the main.c. I didn't get rid of cat.h, but I got rid of cats.dat. Now I'm going to run the program I just compiled, and again, you can do this just by clicking on buttons in your user interface. You don't need to use the terminal for this unless you just want to. Notice the message "one cat's written" right here. That's from that printf you saw in the previous screen where I print out "in cats written." So I succeeded in writing one cat to the file, and sure enough, if I look, I'll have a new cats.dat file. And it's still 80 bytes, and it's just been created this minute because it's 8:45. So let's take a look. Now, I think I warned people about this, but it always confuses folks. This is not a text file, so if you open it with an editor, you'll see funny stuff. For instance, if I just did this, there's a lot of junk in there. You see some text screens, but a lot of junk. That's because this is a binary file, and where everything's a fixed size. So when I stir copied fluffy, FLUFFY, 6 characters, into the 50 character name member of the cat struct, all of the rest of the data after fluffy and in a null is just whatever happened to be in memory at that point. Probably the little diamonds are zeros, but everything else is just junk. Then here's where the color starts. You may remember Fluffy's a dilute calico. There it is, but everything after that is junk. And the very last part here is probably 7.1 as the weight, as a floating point number, but I don't even know what that looks like in text. However, there is a Linux utility that will show us this in a little bit more intelligent fashion. I can do this. I can dump this, and you can see a better formatted printout. There's fluffy. There's the null that C must have at the end of every string. Here's a bunch of junk all the way down to here where the color starts, and it is in fact null terminated. And then somewhere after that, this stuff probably out here is actually a double number with 7.1 in it. So you can't actually make sense of this file except if you fwrite it back into your program. So you fwrite it out. It's very compact. It has all the information in it. It's correctly formatted, not human readable. And when you read it back in using fread, you can convert it back into printable text. We'll do that in the next video.